Welcome back again, folks, to another session of Euclidean geometry. The theorem that we are proving now states that the angle between the tangent to a circle and a chord is equals to the angle subtended by the chord at any point on the circumference of a circle. When we apply this theorem, as a reason, we just say tan chord. Folks, be very careful. I said you should be able to state and understand the theorem. You should be able to prove the theorem. You should be able to recognize and apply it whenever it is required to. Now, I'm going to prove it for you. The proof to it: you will be given a circle with center O, that is important, with tangent PQ and chord QR subtending S on the circumference of a circle. Let me go through this with you again whilst I'm showing you on the diagram. You are given circle with center O, there's your center of the circle, with tangent PQ. There's your tangent there. Remember, the tangent to a circle is the line that touches the circle in two arbitrarily closed points, which would look like one point to our naked eye. Then, from that, we are given chord QR. Chord QR, a chord is a line which is drawn from circumference to circumference but does not pass through the center of the circle. The chord QR is said to be subtending angle S. Let's go to QR. There's QR subtending angle S on the circumference of the circle. There's S on the circumference there. Now, we are required to prove that angle RQP. Let's look at angle RQP. Angle RQP, we are required to prove that this angle, look at that angle. This angle is the angle which is between the tangent and the chord. You are required to prove that it is equal to angle RSQ. Angle RSQ, that angle, which is subtended by this chord on the circumference of a circle, like the theorem stated. Now, how are you going to prove that? Step number one, you are going to construction. Your construction, you are going to draw line. I'm just going to say it is line TOQ. Let me draw that line so that you see it. There's our line TOQ. Very important, this line is passing through the center of the circle, and I'm going to join T to R. I'm now joining T to R. There we go. Now, folks, I want to ask this again. Why do we construct? I told you more than once. We construct so that we bring old theorems into proving new theorems. Now, let's look at that one. Which old theorem did we bring now here? Do you see that TOQ is a diameter to a circle? There's a theorem that says A diameter to a circle subtends a 90 degrees angle at any point on the circumference. That diameter subtends angle R on the circumference. Therefore, angle TRQ is equals to 90 degrees. Now, another theorem that we have brought back, remember cyclic quadrilateral. Cyclic quadrilateral, we had angles on the same segment which were said to be equal. Now, what else did we bring? We have also brought back that axiom which states that a tangent to a circle is perpendicular to a diameter or a radius of the circle at a point of contact. Now, very important, that angle is 90 degrees. Why? Because we have a tangent and a diameter. This angle is 90 degrees. Why is it 90 degrees? It is subtended by the diameter. This angle is equals to that angle, and this angle is equals to that angle. Why is that? Those are angles which are subtended by same chords, or those are angles which are said to be on the same segment. Now, we have brought back more than one theorem, I think 3 of them. Let's prove this theorem now. The proof to it, I'm going to say this is angle R1 and this is angle R2, that is angle Q1, that is angle Q2. Now, I'm going to start by saying angle R1 plus angle R2 is equals to 90 degrees. How do I know that? It is subtended by the diameter. Remember, we just say semicircle. Then I'm going to move on and say, but I know that angle Q1 plus angle Q2 is also equals to 90 degrees. How do I know that? It is because I have got tan diameter. Okay, folks, now I can move this to here so that we don't cramp the space. Let's write them again. Angle R1 plus angle R2 is equals to 90 degrees. What was our reason? The reason was semicircle or subtended by the diameter. Again, we say angle Q1 plus angle Q2 is equals to 90 degrees. What is the reason? The reason is tan diameter or tan radius if you want to. Now, from here, look at this now. In triangle TRQ, that angle is 90 degrees. Now, if this angle is 90 degrees, what do we know about angle T and angle Q1? Let's say angle Q1 plus angle T. What do we know about them? They also add up to 90 degrees because this is 90, that and that would be 90 degrees, so that this is 180. They add up to 90 degrees. Now, the reason would be sum of angles of a triangle. Now, let's look at this. We want to relate this angle into that angle. Let's move this right here to there. I'm sorry about that. We want to relate this angle into that particular angle. Now, it means here I must say Q2. There it was Q1 and Q2, it is fine. Now, relating this angle into that particular angle, it means that I must be careful with the statement that I'm taking. I am going to take this one and I am going to relate it to this one. I want Q2 and I want R there. R1. No, not this one. This one. Yes, yes, beautiful. Now, this is 90 and 90. That means I can say, therefore, angle Q1 plus angle Q2 is equals to angle Q2 plus angle T. Why is that the case? Can you see that both of them are adding up to 90 degrees? Now, when we group these two, you can see that that is going to cancel that. When I add the additive inverse, taking this into the outside to be negative, it will cancel. Now that means angle Q1 is exactly the same as angle T. I have now proved that this angle is equals to that angle. But what did they say I should prove? They said I should prove that angle RQP, I must prove that angle RQP, this angle, is equals to angle RSQ, is equals to angle RSQ. But instead of proving that this is equals to that, my proof here is giving me that this is equals to that. Must I cry now? No, I'm not gonna cry, because I know that this angle is equals to that angle. Then I'm just going to say, but, let's write it there, but angle S is equals to angle T. What is the reason? Same segment, or subtended by the same chord. Now, look at this. There's angle T and angle T there. Angle Q1 is equals to angle T. Angle S is equals to angle T. I can now conclude and say, therefore, angle Q1 is equals to angle S, because both of them are equal to angle T. Now, what did we prove here, folks? We have proved that indeed the angle between the tangent and the chord is exactly the same as the angle subtended by the chord on the alternating segment. Folks, I'm reminding you again, be able to state the theorem, be able to prove the theorem, you will be able to apply it. And your logic is very important towards the proof. Thank you very much. Like us and subscribe.